Well, we're going to solve this expression, and we are going to do that using natural logarithms. We need to apply the natural logarithms on both sides, and then on this side, as we can see, we can also apply the properties of the logarithms and bring down the exponent. And then the next step is to derive this expression. And well, in this part we have a product rule by derivative, so we solve it normally as a product rule, and all of this is multiplied by y, so that we can eliminate this y with this one and only have then the derivative of y. And then we only, as this side was multiplied, we have a y multiplying all of this. Therefore, that is where we put the initial expression in y, and all of this multiplied by the simplification of this expression, and that will be the final answer.
First, when we see this problem, we know we have to use rules of natural logs. So we know that after this we will have b prime and u prime, and after this we know we have to use the product rule to solve it. So after the multiplication and the sum, we will have minus sine multiplied by natural log of x plus cos of x divided by x, and all of this will be multiplied by y to get y prime, which is what we're looking for. So after we eliminate the y, we will have this expression, and after that we will just add normal y, which is the first equation, and this will be the final answer.
So we have this expression, and we can solve it by using the properties of natural logarithms. So the first step is to take the natural logarithm in both sides, here and in here. And now that we have this expression, we can simplify it using the logarithmic properties. When two are multiplying, you can add them, like in this expression. And after that, we can take these values, that are the exponents, with the logarithmic properties, you bring them down, like in here, and you make the same with the 1/3. So now we have an expression without exponents, and then the next step is derive the expression. So we take down the argument, and we multiply it by the derivative of the argument. We make the same in here, we take down the argument and we multiply it by the derivative of the argument, and in here we take down the argument and we multiply it by the derivative of the argument. So then you multiply the fractions and you have this expression, and after that you have to bring down this y value into this expression that are going to multiply with the expression that you already derived, and this multiplication is your final answer using natural logarithm method.